This time last year, the cleanup was underway in the aftermath of Hurricane Sandy, which left behind $65 billion in damage and single-handedly led to significant changes in at least two aspects of the U.S. weather enterprise. One big change resulted from a major communications issue. As Sandy neared the coast, the storm was rapidly losing its tropical characteristics, so just before landfall, the National Hurricane Center reclassified Sandy as a post-tropical storm and handed off forecasting responsibilities to the local National Weather Service offices. Because Sandy was not officially tropical anymore, no hurricane watches or warnings were in effect as it approached, even though the storm was still very dangerous, with winds above 80 miles per hour and a large storm surge. This reclassification at such a critical time confused the media, many local authorities, and the public. And as a result, the National Hurricane Center has changed its policy. From now on, they will retain forecasting responsibilities for such storms right through landfall if there's a significant threat to life and property. And any tropical warnings will stay in effect regardless of the storm's official designation. Now, a second big change involves computer modeling. It's no secret that meteorologists rely heavily on numerical weather prediction, NWP for short, to forecast the weather. The computer models run by the U.S. are pretty good, but until Sandy, the general public didn't know that they're not the best in the world. Instead, on average, the model from the European Center for Medium-Range Weather Forecasts, run by a consortium of European countries, is better. Whereas the primary U.S. long-range model picked up on Sandy's left turn towards the coast about 4 days in advance, the European model advertised this unusual path a week ahead of time, and this fact was given great media coverage. The inferiority of U.S. computer modeling is due partly to less powerful computers, and Sandy prompted Congress to appropriate $25 million of a disaster relief bill to the National Weather Service to upgrade its supercomputing capabilities, with the goal of matching the European Center's computing power by the year 2015, with speeds approaching 2,000 trillion calculations per second. Speaking of supercomputing, Sandy's hybrid structure has been recreated in a numerical model in unprecedented detail. Using a grid of 4 billion points to mimic the storm and its surroundings, researchers have reproduced 4 days in Sandy's life in a massive virtual experiment that required 58 hours of supercomputer time. Such high-resolution simulations aren't practical yet in real time, but if they can be shown to add value to the warning process, they could become part of the 10-year Hurricane Forecast Improvement Program currently ongoing within the National Oceanic and Atmospheric Administration. Fred is back next with the extended forecast.